Okay, so we'll start with problems on chapter 12. Tests reveal that a normal driver takes about 0.75 seconds before he or she can react to a situation to avoid a collision. It takes about 3 seconds for the driver having 0.1% alcohol in his system to do the same. If such drivers are traveling on a straight road at 30 miles per hour, which is 44 feet per second, and their cars can decelerate at 2 feet per second square. Do you hear me?
Yes, doctor.
Okay, sorry, قطشت شوية. Okay, so here the idea is we want to determine what will change when we have people driving cars and they drink, because what will change is the reaction time. Okay, the reaction time is the time needed to put your feet on the brakes and to stop your car. So when you see persons on the street, you will activate the brakes, but you have a certain reaction. سوري كثير عم بقطش، ما بعرف ليه. عم تسمعوني او عم بقطش الصوت؟
هلا سامعينك منيح مدام.
بس وقتها كنت عم بشرح كان قطش او كان مسموع؟
لا اخر شيء سمعته عم تسمعوني شيء هيك اخر شيء سمعته. هلا بينت الصورة.
خلص يلا رح ارجع عيد، مش مشكلة. Okay, so here in this problem we want to investigate the difference between a person that is driving the car in normal condition and a person that is has a certain percentage of alcohol in its blood. Okay, so we'll see that whenever you drink alcohol, the reaction time to stop your car will be larger. يعني انتوا تنتبهوا انه في شخص موجود ولازم تدعسوا على البريكس، بتزيد الوقت of reactions. This is the difference. Okay, now we know in this problem the initial velocity v initial v1 is 44 feet per second, and we know what is the distance between the car and the persons. Okay, so here they are asking us to determine this distance, the minimum distance needed to stop our car. Okay, so to do this, we don't know D, but to stop the car, what is the final condition when we reach the persons?
فيتاس مفروض تكون 0.
Exactly. V final, V2 is equal to 0. Okay, so we know the initial velocity, we know the final velocity, but we should pay attention is that here we have two phases during motion. شو هن the two phases that we have during the motion? In the first phase, قبل ما ندعس على البريكس، شو بيكون الموشن تايب؟
قصدك فيتاس constant?
Yes, exactly. So we have two phases here in this motion. Phase 1, V is constant. And we know the value of V. So this velocity is 44 feet per second. And phase 2, we have deceleration. So A is equal to what? They said that the car will decelerate at 2 feet per second square. يعني عنا 2 minus 2 feet per second square. Okay, now what is the difference between the two situations we are comparing? The time of the phases. يعني is a reaction time for a normal driver is 0.75. يعني الphase 1 بس حتطول، يعني delta t for the normal driver and delta tn of phase 1 is just 0.75 seconds. While for the driver that whenever you drink alcohol, you have a certain percentage of alcohol in your system, you need more time to react. So delta t of the driver with a certain percentage of alcohol in his system is 3 seconds. So now because the reaction time is larger, then the distance of the distance d1 moved in phase 1 will be larger for the driver with alcohol compared to the normal driver. Okay, يعني نحن بالتو methods نفس equation, just the difference is delta t. So if you want to compute the total distance traveled, كيف فينا نقسمها؟ d total is equal to d1 plus d2. بما انه in phase 1 the acceleration is constant, then we can just say that d1 is equal to velocity v initial اللي هي 44, okay, times delta t of phase 1. While for phase 2, okay, for phase 2, how can you calculate d2? How to calculate d2 for phase 2? What do we know?
ما نستعمل equations اللي تعلمناهم.
مزبوط. بهول الايكويشنز اللي تعلمناهم شو بنعوز؟ يعني d2 شو هي؟ d2 نحن بنعرف انه for constant acceleration، مش phase 2 عندها constant a. For constant acceleration, okay, we can write that v square final minus v square initial equals to 2a delta s. اوكي، هلا نحن بما انه in phase 1 كانت constant velocity، يعني بعدها الفيلوسيتي هي 44، يعني هون عندنا we replace v initial by 44. بما انه we want to stop at the end of phase 2, v final is 0 and we have that a is -2, so we can calculate delta s اللي هي d2 in phase 2, and d2 will be the same for both persons, for both drivers. So only difference هي بالd1، لانه بالd1 delta t1 للاول حتكون 0.75 بينما delta t1 للثاني حتكون 3 seconds. If you calculate in numbers and you compare numbers, you can see that the total distance needed to stop for the person for a normal driver is just 517 feet, while for the other driver with percentage of alcohol in his system, the distance is larger. يعني بده تقريبا زيادة 100 feet تيوقف. And you know that this is why the risk of accidents will be much higher in case you drink alcohol. Any question on this problem? Another problem. A particle is moving along a straight line with an initial velocity of 6 meters per second when it is subjected to a deceleration of a equal -1.5 v to the power 0.5, where v is in meter per second. Determine how far it travels before it stops and how much time does it take. Always when you have such problems, what is the first step to do? You should select the corresponding differential equation. إذا بتتذكروا نحن بالchapter 12 we have seen several differential relations. We have first A is equal to dv by dt. We have also that velocity is ds by dt. And we have that ADS is equal to VDV. Which one to use depends on the given. Okay, in this problem, what do we have? We have a function of V. Okay, and we want to solve for the total distance traveled. And what are the parameters involved here? أي equation بدكم تستعملوا for this problem? Which one?
Third one and Murphy time.
Exactly, third one, because we don't have a function of time. لو عندنا a function of time, then we use a equals to dv by dt. But because a is an expressed function of v, then we use a ds equal v dv. And because a is function of v, we take it to the side of v, and then we do separation of variables. we do integration. Okay, so if we write here, we can write that minus 1.5 v to the power 0.5 is equal to times ds is equal to v dv. And because a is not function of s, it's function of v, we'll take it to the other side. Now a function of s, we keep it from the side of ds. But since it's expressed function of v, to be able to do the integral process, we take it to the other side. And now we say that for the first side, we just have ds. So we integrate from 0 to s. Of course, here, depending on the boundary condition. هلا هون هن شو عطونا؟ قالوا لنا initially يعني at t equals 0 v equals 6. So because the condition at s equals 0, sorry, يعني نحن we are starting from the origin, okay? And they gave us at the origin, so for s equals 0 v equal to 6. لو قالوا لنا مثلا at s equal 1 v equal to 6, so we don't integrate from 0, we integrate from 1 to s. But because here they are giving us the initial condition, they didn't mention anything. If they don't mention anything, this means that you can consider the initial position as the origin. However, they can tell you in other problems, they can tell you the initial position, for example, is for s equal 2 meters, and we start from here. In this case, you integrate from the initial value of s, from 2 to s, and here from 6 to v. Okay, but here, because they didn't mention anything, we can consider that we started from the origin. So we integrate from 0 to s, and we have from the other side, we integrate from 6 to v. And this equation is simple to integrate, okay, because we have that v over v half is equal to v to the power 1 over 2. And you know that if you have v to the power n and you want to integrate, the integral is v to the power n plus 1 over n plus 1. So all you have to do is to perform the integral, okay? And then you apply between 6 and v, you can find a general relation between s and v. Now, when you replace, what you want to find is the distance before it stops. Because you are searching for s when the car will stop, so the final condition is v final is equal to 0. So all we have to do is to replace v by 0 at the final state to get the total distance traveled. Okay. Now, why we didn't do this from beginning? And why directly we didn't say we integrate directly from 6 to 0? We can do this, but we have a continuation for the problem. We should solve also for how much time does it take. Whenever you have other questions, you might need the function. This is why first they found s function of v, then they replaced v by 0, because in the second step, you need s function of v to find the time. What is the equation that you will use to get the time now?
V equals ds over dt.
Exactly. V equals to ds over dt. And now you will replace v by its value. It's a function. We know that v is ds by dt, and we got already s as a function of v. Okay, because we have already s function of v, so we can replace here in the equation, we can get v function of s and replace v by its value as a function of s. And all we have to do is to rearrange terms, okay? Because we can, from this equation, say, you know, I can take this to the other side. So I have that v is equal to s minus 6.532 over minus 0.444 times radical of 3 over 2. Okay, so in this way, I can get v function of s, And when I replace in the differential equation, I can do separation of variables. So I can take then أو كمان إذا بدكم the other way, okay, يعني this is a possible approach. أو the other way is to use the other relation. يعني نحن عندنا اثنين relation فيهم time. في عندنا v equal to ds by dt. So we can express v function of s and do separation of variable to integrate with respect to time, okay, to find the time. Or what is easier here is to say, we know also that time is involved in a equals dv by dt. And since I have a as a function of v, I can do separation of variable by taking a to the side and taking dt to the other side. So dt is simply dv over a. I replace a by 1.5 times v to the power 1 over 2. And then I integrate from this side from 0 to t, and from this side from 0 to the final velocity, which is 0. So I can get the total time needed. You can verify that if you use the other method, you will also get the same result. إذا بدكم تستعملوا هالمethod, ساعتها you should write ds over v equals to dt. And then when you replace v by its expression as a function of s here, then you integrate from S0 to S final. S final is 6.53. You already calculated it before. Equal to integral from 0 to t final of dt. So you can get t final. So both methods will of course give you the same results. But this function, this one is easier to integrate than this one. This is why I always try to use the easiest method. Okay? Any question on this?
No.
Oh. Car B is traveling a distance d ahead of car A. Both cars are traveling at 60 feet per second when the driver of B suddenly applies the brakes, causing his car to decelerate at 12 feet per second squared. It takes the driver of car A 0.75 seconds to react. This is the normal reaction time for drivers. When he applies his brakes, he decelerates at 15 feet per second squared. Determine the minimum distance d between the cars to avoid the accident or collision. Okay, so here you have two cars, A and B. Initially, both were moving at the same velocity. The initial velocity for both was 60 feet per second. And you have the distance separating them. We want to search for the minimum distance that is separating them to avoid accident. Okay. In order to not have accident, can you give me what are the conditions? What are the conditions to not have accident?
ما يكونوا على ذات الديستنت.
when they meet يعني بس A يلحق B، اوكي؟ وقت A يلحقوا ل B يصيروا بنفس النقطة، شو الكونديشن تما يفوتوا ببعض؟
بقى الفي ما تكون superior than 0 او ما يكونوا على ذات الكوردينيتس قصدي.
اوكي، لازم يكونوا وقت يتلاقوا ببعض لازم على القليل الفيلوسيتي لهم تكون هي ذاتها. يعني لانه اذا الفيلوسيتي اوف A اكبر من الفيلوسيتي للبي حيفوت فيه. اوكي؟ So the condition is when they meet together we should have VA equal to VB at meeting time. اوكي؟ والا هيدا المينيمم يعني اكيد اذا في بي اكبر اتس سيف لانه يعني وقت A تكون لحقته حيكون هو قادر يكون اسرع منها ف حيرجع يبعد عنها. المينيمم انه بس يتلاقوا تكون VA equal VB. اوكي؟ هلا to be able to solve for this we need to write the equation of motion for A and the equation of motion for B. اوكي نحن عندنا انه هو البي اذا بدكم ورا الاي بالعكس يعني عندنا بي او فينا نعتبر انه هن عم يمشوا بهالدايركشن. اوكي they are moving in this direction. فالبي هو لانه وقت الاي when B will apply the brakes okay his car will decelerate. لا مزبوط سوري B بيعمل البريكس اول شيء. okay when B will apply the brakes he decelerates at 12 feet per second square. يعني هو البي عنده phase 1 عنده one phase only. okay اللي هي deceleration A of B is equal to minus 12 feet per second. مين feet per second square؟ مين عنده two phases الA؟ ليه؟ لأنه بس البي يدعس على البريكس مش دغري الA حيدعس على البريكس حياخد شوية وقت. اوكي so هو حينتبه بعد 0.75 second انه يعمل reaction and this is why حيكون عنده two phases. للA حيكون في phase 1 بيكون بعده ماشي على V equal 60 feet and this phase the time of this phase is 0.75 seconds. So this phase will take place from t equal 0 to t equal 0.75. After this, okay, he will pay attention انه البي بطأ يعني هو لازم يبطئ. So you have a second phase بس لانه بينتبه انه ما يفوت فيه بده يعمل deceleration اسرع منه يعني مشان هيك حيدعس على البريكس اقوى من البي حتكون الديسلريشن 15 feet per second square. So in phase 2 the deceleration of A is equal to minus 15 feet per second square. Okay, now let us write the equations for the two cars A and B. Okay, to start with for B مثل ما قلنا B عنده one phase he deceleration at constant value. So all we have to apply is VB equal V0 which is 60. So this is V0 of B. Plus acceleration times time because it's a deceleration and we are moving in the positive direction like this. So A should be opposing V and should be negative. So minus 12t. And for constant deceleration, what is the equation for S? We have the right directly to apply it. It's equal to S0 plus V0t plus half AC t squared. Okay. So now in this problem, المهم بدنا ناخذ الأوريجين. احنا عندنا A وعندنا B. اوكي فينا ناخذ الاوريجين اذا بدكم الانيشال بوزيشن اوف A وقتها بلش البي يدعس على البريكس. So initially اذا هيدا الاوريجين تبعنا اوكي كان البي at a certain distance from A. نحن we want to determine what should be the minimum distance, the initial distance بيناتهم to not have collision. So we should solve for this distance. هيدي D represents the initial coordinate of B. Okay, so SB is equal to D plus 60T اللي هي V0 times T minus 60 squared. So this is the equation for B. Now we move to write the equations of A. For A, as we mentioned, we have two phases. Okay, we have phase 1 and phase 2. Okay, so نحن تكان انتبه ال A يدعس على البريكس already كان مرق a certain distance. Okay, so to determine if you want this, we should write two equations. We should write an equation for the velocity variation for t larger than 0.75. For t larger than 0.75 seconds كيف بتتأثر الvelocity؟ الvelocity بتصير V0 plus AC times T. بس بدكم تنتبهوا إنه time T هون of deceleration is not the same time للB لأنه ال A بلش يعمل deceleration after B. Okay, وقد إيه الفرق بالتايم؟ 0.75 seconds. يعني we can say that we have the equation of deceleration حتبلش بعد 0.75 seconds. And since we don't want to change the origin of time, يعني نحن T equal 0 بالنسبة لنا هو لما ال A لما ال B دعس على البريكس. Okay, T equal 0 correspond to B start deceleration. بما انه ال A حيتأخر عنه شوي. Okay, to take this into consideration بالequation, for A the time T is equal to T minus 0.75 لأنه بلش يعمل deceleration بعد 0.75 seconds من B. So we just have to replace here delta T يعني T minus 0.75. Okay, and this will be the equation of velocity for T larger than 0.75. هلا تنعرف ال S in this phase بدنا ننتبه إنه هيدي الفيز بلشت after phase 1 يعني الزيرو لإلها مش زيرو. أوكي، لأنه نحن شو حيصير؟ كان A هيدا الأوريجين وقتها B عمل deceleration A كان بعد مش منتبه مشي a certain phase at constant velocity يعني for 0.75 seconds كان ماشي على constant velocity. So what is the distance traveled during this time؟ نحن بنعرف for V constant, if V is equal to constant, then delta S of A for phase 1, delta SA for phase 1 is equal to the constant velocity VA in phase 1 times delta T اللي هو reaction time delta T of phase 1. So it's equal to 60 times 0.75. يعني وقت خلصت الفيز 1 وين كانت البوزيشن لل A كان already A مشي distance 60 times 0.75. يعني بالنسبة له الS0 الزيرو مش يعني S at T equal 0 يعني S at the beginning of the phase بالنسبة لنا هون. At the beginning of phase 2 A كان already ماشي a certain distance يعني هو كان بعيد عن الأوريجين a distance of 60 times 0.75. So this is for phase 2, this is the initial condition Z as 0. Okay, so this is the distance, the position of A لما دعس بلش يدعس على البريكس plus what is the initial velocity at this time? He is 60. Okay, يعني هو وقت انتبه انه لازم يدعس على البريكس هلا بلش يدعس كانت الفيلوسيتي له 60. And because the time for phase 2 is starting at 0.75 seconds after B يعني شو بتكون التايم بهالايكويشن؟ بتكون T minus 0.75 minus half AT square. ال A هي deceleration هي minus 15, so we put A equal minus 15 and also T مثل العادة لأنه نحن الفيز 2 بلشت بعد 0.75 يعني التايم لها هو T minus 0.75 square. هون بس it's a typing error. This is T larger than 0.75. So now we have the equation for SA, SB, and we have the relations for VA, VB. All we have to do now is to say when they reach each other لازم minimum to be on the safe side لازم على القليل تكون velocities equal. okay أو هيدا المينيمم بينما إذا VB أكبر من VA كمان we are on the safe side. okay so the most critical condition هي إنه when they reach each other VA is equal to VB. Since we have the expression of VA and VB we all have to do is to replace. And the only unknown in this equation will be the time. So we can get the time needed, okay, to satisfy this condition. Once جبنا هيدا time, we can replace in the equation of SB, okay, in motion relation of SB and SA, okay, to get then what is the value of the distance. انتوا بتعرفوا انه at this instant, so once you get the time T, you can replace here, okay? Then you get SA. بس هن تلاقوا ببعض يعني SA صارت equal ل SB. So at this time SA will be equal to SB. So once you replace time here, you can get the value of SA. And saying that SA is equal to SB at this time, you can get what is the minimum value for D. Okay. Any question on this? Please, if anything is not clear, ask. Okay. Another problem. The acceleration of a particle along a straight line is defined by A equals 2t minus 9 meter per second squared, where t is in seconds. At t equals 0, s is 1 meter, and v is 10 meters per second. When t equals to...
فيك تعمل شوية صغيرة زوم؟
إيه أكيد. Yeah. منيحة هيك؟
إذا بدك كبريها شوي أحسن ما تكون كثير عاملة.
Okay.
Merci.
Welcome. Okay. So we have that the acceleration of a particle along a straight line is defined function of time by A equal to t minus 9 meter per second square, where t is in seconds. They gave us a boundary condition that at t equals 0, s is equal to 1 meter, and v is equal to 10 meters per second. Now, when t equal to 9 seconds, we want to determine the particle's position, the total distance traveled, and the velocity of the particle. Okay, whenever they ask you for this, بس يقولوا لكم total distance, please انتبهوا. Total distance مش يعني S. شو الفرق بين S و total distance؟
S هي البوزيشن، total distance يعني هي قد ايه رحت واجت.
Very good, exactly. S will just give you the position of your particle. أي متى ال S with total distance بيكونوا equal؟ يعني دلتا S.
ضل تمام ثانية، ضل رايح جالس مثلا أو رايح لورا.
إذا ضل رايح ب one direction، أوكي؟ إذا ماشي مثلا بالpositive direction بس، ساعتها دلتا S بتكون equal to d total. وإذا ماشي بالنيجاتيف direction وما عم بيغير، يعني عم بيضلوا على طول بالنيجاتيف direction، اوكي، بتكون دلتا S equal minus d total. اوكي، بينما إذا غير direction شو بيصير؟ إجباري إنه بتبطل التوتال distance equal to delta S. So this will not hold if we have change in direction. فعلى طول بس يسألوكم to compute the total distance, you should draw the path of motion تتعرفوا أي متى راح بالpositive direction أي متى راح بالnegative direction. How can you do this? مين بيخبركم أي متى بيروح بالpositive أي متى بالnegative؟
الساين تبع في.
Exactly, sign تبع V. So here the first step will be to get V function of time, S function of time, and study the sign of velocity. ساعتها فينا نعرف من from which time to which time it's moving in the positive direction and in what time it's moving in the negative direction. ساعتها بس نرسم ال plot of path of motion بيصير فينا نحدد total distance travel. So as a first step we want to get V and S function of time. Okay, since A is given function of time, هننطلق من A equals 2dV by dt. And since A is given function of time, شو بنعمل؟ بناخد dt to the other side. بنعمل separation of variables and we integrate. So we know that at t equal 0, V equal 10. So we'll integrate time from 0 to t. And we'll integrate velocity for t equals 0, velocity is 10. We'll integrate velocity from 10 to v. And then we can get the equation of v as a function of time. Okay, so this is v function of time. Now, once we have v function of time, we can solve for v equals 0. تنعرف أي متى كانت v positive وأي متى كانت v negative. Okay, so this is the equation of V. Let us say this is equal, we'll take t into factor, t factor t minus 9. So we can say that v is equal to 0 for 2 times. V equal to 0 for t equals 0 and for t equal 9. Okay, so we can deduce that the velocity will be sorry ما انتبهنا انه لازم ناخذ 10 لتاني مات sorry. Okay, في 10 هون, so you should take it to the other side. Okay, يعني بصير عندنا second degree equation. عندنا second degree equation بنحطها على الكالكوليتر and we solve for the two solutions T1 and T2. Okay, so we have T1 equal هتطلع ل 7.7 seconds and T2 equals to 1.298 seconds. يعني هول التو times اوكي يلي بتوقف فيهم الكار او البارتيكل. So what we should do here then, if we draw the table of sign, خلينا نرسم التable of sign للvelocity.